This is a brand new program. Okay. Now, I'm just going to copy so far, and then come to here, delete everything first, and then paste it. So far, does everybody able to reproducing whatever I do? Next thing, of course, you have the plug-in, eh? You keep your Arduino plug-in, remember that. Now, next thing, I need to save it as a new, give him any name. You can give him just a simple one. Once I save it, I can upload. See the upload? Everybody see the upload here? The moment you click the upload, the program will be loaded into the Arduino. You will see the LED blinking. There's a two small LED. Now, once I click it, you can see it compiling and then doing this. So there's a two LED right beside the red one is the blinking, okay? So what does it mean? The program is uploading into the Arduino itself. Go to your upper right-hand corner, serial monitor. You click, it should have a new screen pop up. You can clean it. You can clean the output. At the beginning, it should have some weird character. Now, next thing is going to see the baud rate below. See that there's a list of baud rate. Choosing 115200 baud rate, and then you can clean the output. That means now find a small using a pen.
Daniel says that he has no strange characters on his screen, while Nathan asks, what is baud for?
The baud rate? The baud?
The B-A-U-D. Baud.
It's the communication speed. Now, if you guys can see the red button inside, you push it using a pen to push it. It will resetting the program at the beginning. If you pushing this again, it will basically restarting the program again. My question is, can everybody, when they pushing the red button, they seeing this kind of display? Now, provided you have the baud rate set it correctly into 115200. Everybody get it? Everybody able to reproducing whatever we're doing?
Daniel says it works. Nathan says it works. Got it.
Seeing some string character at the beginning, but once the program start, you can see the program displaying.
Tiffany, Nathan, and Rohit says it works. Daniel says he sees the characters.
But when you see a string character, does it continue to work? That's just important. Like at the beginning, it may seeing, usually if you're seeing a string character, it's meaning the program is doing the setup, the initial baud rate. The program at the beginning is that I'm going to using my communication port, which are using the baud rate. This is the baud rate. The baud rate is a serial communication speed. Okay, so basically you can defining a very fast, but I think 11, 12, 5200 is the fastest baud rate support. You can define a slower one, but slower meaning you don't display very quick. So this is the good baud rate for general speaking for the Arduino. Okay, so what it does is I'm going to my program using a serial port to send the information out. Now, then I just as the same as before, I'm going to using my pin 13, which is the internal LED as the output, and I'm going to display one empty line, meaning this line, okay. And then I'm going to display another line which we have the dot, 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 dot here, which is this line. And then I'm going to display a value, FF defining equal. It's a constant value. And then I'm going to display a, in this case, it's a define, meaning it's a macro. It's a high, meaning I put 1 here. So it means this line is always displaying this. Doesn't matter how many times I'm doing it, it's always displaying this because it's not variable. And I'm going to have an, now, interesting thing is I have 2 pin statement. I have 2 pin. One is I have an LN. LN means line fit, meaning after this, please go to next line, okay? If I don't have this one, it will stay in here. It will just display and stay in here. It will display and come on. It will display and stay in here, and then display 1. And LN means next line. We'll go into next line. And flip-flop, same thing. We will stay here up to this line. And then when the flip-flop, we will getting the variable. Now remember previously we talked about a program. It will go into a location, which is a flip-flop location. It getting the value out. At this moment is high, it's 1. So we're going to display the 1 here. Okay. Now the program is going to a loop. This loop is a very simple one. All it does is it displaying the counter. It's another variable. Initial is 0, and then going to display the flip-flop location, flip-flop value. Now, I remember we telling you before, FF define is a macro. So this one doesn't matter how many times you do it, it's always value 1. It's just substituted by 1. So it doesn't matter how many times I execute, this line will be only 1. It will always display equal to 1. That's it, continuous. And then the next statement here, I will display the variable flip-flop. This flip-flop, it will going to the storage location to getting the value out and display it. So because later on my logic will be changing the value. So you can see it's switching from 1, 0, flip-flop. It's doing the flip-flop, okay? So this 3 line, we're generating 1 line here. If you don't want to see the time, you don't want to see the timestamp, you can get rid of this timestamp. You can get rid of the timestamp. So when the time is displayed, let me clean it. Sorry. See right now, there's no more timestamp. If you click it, it will get you back the timestamp. You don't want to see the timestamp. It will just do not see the timestamp. Okay. Let me just reset it and do it again one more time. Okay. And I'm just pushing my red button to reset it so I can show you at the beginning. Now, at this moment, this 3 particular line on your left-hand side will producing 1 line here as the output. So the next statement in the program is it will doing the conditional if. It will getting the value from a flip-flop. If the equal to equal meaning is equivalence, equal to equal means equivalence is a 1. Then I will changing the value to 0. I will assigning the low value into flip-flop. This is mean assigning the value to the flip-flop. Else, I will assign to high. Now, when is this one going to happen is when the time this one is not high, then it will changing to here, okay? Else. You were wondering why we have a curly sign here. Maybe go to the program. Why we have a curly sign here and not a curly sign here? In the C program, if can have 1 statement here and can have one statement. When you have a query sign, you can consider as one statement. So I can have few more things, counter, I'm just making it up, okay? Counter equal to 4, let's say equal to 3. That is considered two statements. But if you put the query sign, it's considered one statement for the else. Since this one is only one, so it doesn't need the query sign. But if you put the query sign here, it won't hurt. So some people, they like to put the query sign everywhere to make sure when they have a more statement inside, everything is still working. So you don't have to remember, I have one statement here and I don't need a query sign. I have a 2 segment, 3 segment, or even more statement, I will have a query sign. So this is a personal preference, but from this program, I can show you because we only have one statement for the if. I don't need a query sign. In the next one, even though I have one statement here, I still put in a query sign. Logically, they are identical, right? The next thing is I'm going to writing this flip-flop value to the LED. That's why you can see every time it change around 1 second, delay 1 second, the LED will change on, off, because this loop is continue looping. Now, if you look at the thing behind, of course, the counter is continue. I just asking not to scroll. If I asking them to scroll, it will continue to scroll, okay? Now, the first number is the counter. So the counter is keep increasing. The first one is 0, and then every time it's just increasing by 1. Remember this statement here? So it will increase by 1, and then display it in the first line here. So you can see the program. I mean, this program is not it's basically doing nothing, but it show you two things. One, you can using a serial, the serial port, which is the monitor. Okay, this monitor to displaying something like, because this is the hardware. For us, we don't know what's inside, and if the thing doesn't work, we're making a logical error. We won't be able to understand what's going on. Okay, so you can using the serial monitor to put the pin statement, just like this one. And then you can display the value on your monitor. So to help you to understand, I'm making a mistake. I should assigning a value to other variables. So that's why my program doesn't work. Okay, now, when we're dealing with a hardware like this, obviously, sometimes you have a connection error. You may have a negative, positive, reversed it. You may have a resistor pointing, put in a different location. Now, this is the hardware side. When the time you're programming this device, you need some software, some tools to help you to doing the debugging. So Arduino have this serial monitor, okay, to help you to displaying the value inside, so allow you to doing your internal debugging. Now, obviously, this program, this FF defining equal to 1 is useless. So I personally would just comment it out because it doesn't do anything. And then I can recompile again, upload again. So you can see your program is only displaying a more essential thing. I just changing my program a little bit now. If everybody see it, you can see there's a string character at the beginning. This is a string character. This is basically the initialization of the monitor, the serial monitor. You can ignore it, but after that, it won't display it anymore. So this program, when it execute it, it will display the initial part, which is from the setup, from the top. And then once it's going to the loop, it will just display the counter. This is the counter, okay? Sorry, this is the count. The the first number is a counter, and then it's displaying the flip-flop value because I comment out this one. It's useless. I mean, it's always display 1. So once we know that it's equal to 1, we don't need to worry about it. So this is how you're doing your debugging. In case, like, remember, this is hardware. It doesn't have a monitor connected, nothing. So you need this kind of thing to allow you to understand what's going on. You can continue. I mean, it doesn't hurt. You can kill it, and you can kill your monitor anytime you want it. You can restarting your monitor anytime you want it. It will just continue to execute. Every time you start the program, starting at the beginning. So you can see it's starting from the beginning. So now, let's say I kill it again, and then I restart. The moment I restart, this Arduino is starting from the first statement. See this one here? Okay, and then I continue. The counter is back to 0 because everything is back to initialization. This one is the same program. It's much longer. I comment out everything with a syntax error, like this one. Why I commented this error? Why I commented out? Because when I just get rid of this comment, this two comment line, it will have a syntax error. Why the syntax error? Now, I'm just very quickly go through it, let you understand what's going on. I'm defining another flip-flop on the setup. And when the time I compile it, this flip-flop is not known. It doesn't know what is the flip-flop because according to the scope, this lowercase flip-flop is only valid within this range. If you using this flip-flop value in this program, it will say, I don't know what this lowercase flip-flop mean because it doesn't know within this scope. Within this scope, we call a scope, meaning this range. It doesn't know what is a flip-flop. Flip-flop is only defined within this range. Now, how come the other one it know? Because it's defining outside. This outside is applying, the scope is applying to everything. This is the local scope. So it only seeing the flip-flop inside. This one, it doesn't know it. So when the time you uncomment this one, you will have a syntax error. Now, this one you see it before like our previous example because it's referring to this outside the scope. So it will know this one is okay. Okay. The next one, if you uncomment this one, you have a compilation error. Why? Because when the time it translate, it will translate to 1 equal to 10. In computer, it cannot assigning value 10 into the value 1. So remember, we have this one defined as a high. High is 1 basically. So this one will eventually translate 1 equal to 10. This is assignment statement. When I say equal, it's equal sign. It's not the equal equivalent mean. In this we call assignment statement. We assign value 10 into 1. That is definitely an error. Okay. So basically, if this is defined as mean a constant, you cannot assign a constant to a constant. And this is the scope, meaning you have to define this variable inside this scope and not outside. I mean, this is outside, so it cannot be referring to it. I guess you will find a difficulty to understand this one, but if you download it and put it into your IDE, compile it. Once you compile it, you can uncomment this one. You will see the compilation error. Okay. I mean, you have to try your experiment yourself. Why this is a compilation error? I'm explaining it in here, and when the time you have a compilation error, this output area will explain it a little bit more. All right. explain it now. Basically, on this side, and we have an equivalence to loop this loop into here. So we're just doing a similar thing to explaining how the inside the program being worked. So what it does is that in this particular line, let me get back this one. In this particular line, I'm sending these to the serial. FF underscore def is a constant, it's a string, it's a constant. And then this guy is defining as a high. FF underscore is defining as a high, meaning this line. So this one is always 1. So it doesn't matter how many times I execute, it's always value 1. So the next statement here, I am sending to serial port, comma, flip-flop equal is a string, and then the value from this location, which is, I don't know where, but when the time the program compile, it will remember, oh, number 3 is the flip-flop location, which is I'm defining here, okay? So the program we're going to read the value inside. What the value at this moment is 1. So we're reading the 1, and then, and using the value here, reading it again from 3, and if equal to high, meaning equal to 1, then it will assigning the value low, meaning the value 0, back to, write it back to the number 3 location. So if my program executes correctly by the end of this line, this programming counter, this value should become 0. And then because it's else, so it doesn't execute this other side jumping out, okay, jumping out. And then it writing the value from 3, meaning reading again, into pin 13. It becomes 0. Remember we just a few moments ago, we assigning value 0 to number 3. So when the time we read it again, this will be a value 0 to pin 13, meaning the LED will shut down, turn off, sorry. Now, and then this is the trick part. This is tricky part. I'm reading the value number 4, which is the counter from here. And then I'm adding the value 1. I save it back to the location number 4. So I take the counter out, whatever the counter value maybe at that time is 10. Added 1 become 11. I save it back to here, 11. So when this continue to working, this counter will the next time will back 10 the value 11 out. Add 1 become 12. Put it back become 13. Next time when it run again, take the value out 13 plus 1 become 14. Put it back become 14 here. Okay. Now this is how the program you can. Using your mind to imagine how this program inside the memory, how it works. This is how the computer, even though a huge computer, big computer, fast computer, they doing exactly the same way, except they may doing much faster. Okay, they may making the thing more complicated, but down to the bottom line, they are internally they still doing this simple instruction one by one, but they doing really really fast. Simple C program, how it working, how the memory internal, how the memory is working together, how to enable the debugging. So you can see how the program execution when you have the debugging turned on. So, I mean, at least you can see what inside the hardware. How do it able to, like it don't have a display. So the only way to tell you what's working on inside is through this serial monitor. Tonight, if you can go home and doing this connection yourself to prepare next time. This connection is not difficult to understand it. What it does is you have two bare board. You're already using one. Don't destroy it because we're going to continue to use it. Using the other one, and you should have two buttons, okay? And then you can have the two buttons and one transistor, like have this diagram. And then I show you how the button look like. The button you put it in, this one is correct. If you put in the leg in the sideway, it's wrong, okay? And the moment you put inside this cause a so-called a push button, because this yellow inside is connected. So meaning, let me see, I can enlarge it a little bit. Okay. Internally, this two is connected. Okay, this two yellow thing is connecting inside. So when the time you push a button, they just sorting these two together. All right, so that's why you can have the red, the positive connected. All this thing become a red, I mean positive. And when the time you're connecting to the other side, this is the transistor. And this one will be connected together. All right, this preparation is not that difficult. So all you have to bring in another backboard, put in two buttons inside. Remember, this is orientation, okay? Don't doing this, this is wrong, doing this. And once you connect, you can have the positive on the top. Usually this is what we're doing. And the negative on here, sorry. And then the negative, you are connecting to this negative or connecting to this negative. Depends on what do you want. Okay, so you have this positive and negative plus this pin to the D10, and then you have a small program. You can do it yourself. Now, what this program doing is very simple one. It's just defining two buttons. You have a pin 9 and pin 10, two buttons, and then you have a built-in LED. So whenever you're pushing the button, if you push it together, this is meaning you push it together. They both in the push into position. Then you will turn on the LED. If one of them is push, it should be not turning on. All right?
Enrique, do we get the 5-volt from the power side?
Yeah. So remember I showed you this one here? Remember? On the picture? This one is V in ground plus 5. Okay? You can connecting this plus 5 into here. Why are we doing this? Because next time we are going to explaining to combining with our traffic light. You remember we have traffic light, I tell you don't destroy it. Because when the time you want to walk over, you want to cross the street, you want to push button to changing the red. Okay, this program, this one, once you're doing this one, I explain what's going on, then we can just get rid of the second button. We can get rid of second button. And then to continue our experiment with a traffic light have a push button. It don't have a positive and negative. All this, they have just, this is connected and this is connected. So usually in our mind, we said, okay, this is all the red positive connected. This is all the black positive connected. So this is how we're using this small. Now, the big one, usually they have the color. They're saying, okay, this is connecting to the positive. And this bottom, they have a color to saying this is connecting to negative. So this is they're using the big one, okay? They have this symbol, but using a small one or small one like this, green or the orange is the same. They don't have, remember the top is not connected. Here is the connection. Everybody see my camera? So John, you maybe you can telling them how to turn on the view.
If you want to see both screens at the same time to any good degree, go to View on your top right corner of the screen, and then from there you can pick a side-by-side gallery or speaker. If you want to see much more clearly, pick Speaker, side-by-side speaker, and then you can just move the windows to enlarge either one.
Now, in case you have this small breadboard, okay, the small breadboard doesn't, the top is not connected. Here is a connection, okay? So let me show you one of the example. This is the two button I want you to try. So I am using this as a positive, and the bottom is a negative. You have to using your imagination. The first column, they are connected, right? So when I put the positive from the 5 volt, here, the whole row is positive. And same thing in the bottom, I connecting to negative. And then this whole column become a negative. So that's why in the picture, this picture, you can see this row, column number 1, once they connecting the positive, they become a positive. They become basically this line. And the bottom column here, when I connect a negative, meaning here, I will just assuming this is the negative. So this is the negative. And this 470 is here and connecting to the button. So we're connecting the button. Okay. Remember, this two is the connection point. So the other positive side, we're connecting to positive. So we jump it back to the positive. This is the connection diagram, and this is the program. All right.
Okay, bye. Thank you.
All right. Bye bye.